All right, today we are going to learn a few more things with logs. So we're going to graph equations of real-world problems using a graphing calculator with an appropriate window. And then we are going to look at a graph and write an exponential or logarithmic function. You will need a graphing calculator today. So here's our first one. This is for the magnitude of an earthquake. It's given by that function where E is energy released by the earthquake. We're going to graph the function using a calculator. Use your graph to approximate the amount of energy released by the 2005 California earthquake with a Richter magnitude of 4.1. So, what we need to look at here is they have given us the magnitude of 4.1. That's a Richter magnitude, which we saw up there is R. So we are plugging 4.1 in for R. And we are needing to solve for E. And this is not E, the number E. This is E, the variable for energy. And we don't know how to solve that by hand yet, so we are going to use our graphing calculator. So our Y1 will be either one of these equations, so we'll put that in Y1, this side in Y2. So we're going to go to our graphing calculator now and put those in. So in our Y1, I'm going to put 4.1, and then in Y2, I'm going to put 0.67. And this is log base 10 because it doesn't have a base, so we just use that log button. 0.37, and for the E, we're going to use X as our variable. And, oops, messed that up. 0.67 log of 0.37 X, close parentheses, plus 1.46. And when we graph this, we will see that, I need to zoom standard first, that that logarithmic function is going to grow very slowly. So it's going to take a long time to get to 4.1, which means there's a lot of energy that's going to be released. And so on that, there is a hint to count by 5,000s. So I'm going to change my window, and we just need to change X. Go to our X max, and we're going to change it to 30,000. And we're going to change our scale to go by 5,000s. You don't have to do that. It just makes the graph look a little bit better. So we're going to graph that. And we can see where we think it's going to intersect. So let's see if they're actually intersecting there. You can kind of see that they are overlapping. So second calc intersect. We're going to hit enter 3 times. And we have our intersection at 23,555.742. So I'm going to go back, and that is my answer to the question. So that is energy, and energy was in kilowatt hours. So my E is 23,555.742 kilowatt hours. So that is how much energy has been released. And always remember that you are to provide a graph. So our graph looked like this, and this was at 4.1, and then you could put your point of intersection there if you wanted to, but a sketch of the graph is fine. Okay, now we are going to look at the graph and find what the exponential or logarithmic function is. So we're given that it's either a translation of y equals 2 to the x or y equals log base 2 of x. And then we are going to move that translation. Okay, so when we consider an exponential function or a logarithmic function, we are going to decide whether we see a horizontal asymptote or a vertical asymptote. If we have a horizontal asymptote, okay, so if we have a horizontal asymptote, that is going to be an exponential function. If we have a vertical asymptote, then it's a logarithmic function. So we saw that when we were graphing logs, that it was a vertical asymptote. So when I look at this graph, it appears to have a horizontal asymptote right here, which tells me that it is an exponential function. So y equals 2 to the x. I've given you 2 points on the graph, and those 2 points are going to correspond to if I plug in 0 and 1 into the function. So 2 to the 0, we're plugging it in here to 2 to the x. So 2 to the 0 is 1, and 2 to the first is 2. So our original parent function is going to be at 0, 1, and 1, 2. So those 2 points are the original function. So it looks something like that, and it has been moved there. So we are going to come up with our translation. So be careful on the scale here. It looks like I have gone left 2 and up 1, 2, 3. And our asymptote here is at y equals 3. So that's a giveaway for our shift up. So I went left 2 and up 3. So in my function that I'm going to write, I am going to have y equals 2 to the x, and this is where I do the left 2. Remember, it's always opposite. It's x minus h. So h would be a negative 2, which gives me x plus 2. And then it goes up 3, so I'm going to have a plus 3 on the outside here. So this is my function that corresponds to the graph that was given. Okay, so you're always going to plug in 0 and 1, and that's going to correspond with the points that are given on the graph. We're going to try one more. We have this graph, and we have to decide whether it's a log or an exponential. And when I look at the graph, it appears to be a logarithmic function because I have a vertical asymptote right here. And if you can't quite tell, you could try plugging in 0 and 1 and seeing if they go with those 2 points. If they don't, then you chose the wrong function. So we are going to plug in 0 and 1 into our log. But remember, when we graph logs, we are going to change the form so that it is easier for us to plug those in. So we have the base of 2 to the y equals x. This is not an exponential function because x is not in the exponent. So then we're going to plug in 0 and 1, but instead of plugging them in for x, we're plugging them in for y. So 2 to the 0 is 1, and 2 to the 1 is 2. So our points here are 1, 0, and 2, 1. So this is our parent function, and it has been moved to those 2 points. So all the points have been translated. We can tell that they moved to the right 1. Our asymptote here is at x equals 1, so that's a giveaway there. So we are moving right 1. And it looks like we are moving down 2. So our function, the right 1 is going to go on the inside of the log. So y equals log base 2 of, and remember this is x minus h, so it will become x minus 1, because we're going to the right 1. And then down 2, that's going to be on the outside of the log, which means outside of the parentheses, minus 2. And that is our function that goes with that graph. So again, you can go back and rewatch parts of these videos. If you have questions, feel free to email me.